So today's our topic is force oscillation and resonance. So force is given by externally, that formula is F0 cos omega dt. So this force is applied by external, and FO, that is constant term, means it is maximum, it is called amplitude of the force, and our force is depend on cosine function. What is omega d? Omega d is forced frequency. So that force we have to write here, or F means ma, right? So ma of t is equal to, again, one force that we have to add here. So applied force is opposite to resistive force. This is restoring force, which is opposite to applied force. This is also opposite to applied force because this is resistive force. So this sum of all the forces is ma of t, right? So that's why here we have to write positive and these are negative, because these two are exactly opposite direction of this. So ma means m d2, second differential equation of distance, plus b, that means this term left hand side becomes positive, so b dx by dt plus kx left hand side, that's why. So f0 cos omega dt as it is. Now solution of this equation is x of t is equal to a cos omega dt plus phi, right? So phi is the phase difference, it is called the phase of our displacement. Now amplitude, so total amplitude is A is equal to amplitude of force upon m square omega square minus omega d square square plus omega d square b square whole bracket complete raised to 1 by 2. So this is the solution of amplitude of our object. We know that omega d is force frequency and omega is natural frequency. So we can find tan phi is equal to minus v0 omega dx0. So what is v0 x0? v0 is velocity, speed, x0 is distance. So these are at t is equal to 0 timing. Now first case, if we are having small damping, means driving frequency far from natural frequency. So at that time we are having A as this formula, because this B term becomes 0. That's why we are only left with this term, square 1 by 2 cancel out. So we are left with this A value, A formula. Second, driving frequency close to natural frequency. It means high damping, means A is equal to F0 omega dB. That means this term only. So from here omega will be cancelled out, it is neglected. So that's why omega term cancel out, and that's why here in this term omega d is also very small. That's why omega d is in with here. So it is in subtraction. Because of subtraction we have to neglect this. So that's why we are only left with this term. So that's why. Now we have to study about resonance. What is resonance? Whenever our applied frequency is similar, is equal to natural frequency, then this phenomenon occurs. So here whenever omega will be omega d, that means resonance. Now to study resonance, I have one example. So here we are having one rod, right? So on this rod we are having different balls which is hanged with fixed point, right? So first, then second of larger length, then again third with same length of first. So first and third have same length, and fourth one is here. It is somewhat less larger than second, but very high larger than third, right? So that is our fourth one, right? So these types of arrangement that we have in this process. So in this resonance, see 1 and 3 have similar length. Now what we have to do? We have to just oscillation by external force. We have to apply oscillations to first. So then after that second oscillate, then third oscillate start, then fourth oscillation starts. Now after some time what happens? this second and fourth oscillations are vanished. So these oscillations will be vanished, and only 1 and 3 oscillations continue, and they are oscillate with same frequency, with same amplitude. So their timings are also same. They are going in this direction, so both are going in this direction, both are going in that direction. So what is the reason for that? The reason is they are having same length. That's why if I am applying some force, after that their frequencies were matching, and because of frequency match we have resonance phenomenon here. So that's why applied frequency is equal to natural frequency. That's why we get resonance here. Similar, many times we heard that whenever some battalion is going through some bridges, they don't want to have that marching. They don't means they advise to do not do marching on the bridges. Why? Because there are many soldiers, group of soldiers. If they are marching in same frequency, then because of that frequency resonance phenomenon occurs, and then bridge will be so much vibrating then, and because of the vibration bridge may collapse. That's why that is advisable that the battalion do not have to do marching on the bridges. So that is the example of resonance. Thank you very much.